Hello and welcome to this short talk on AMD's journey towards open source OpenBMC. This is your friendly speaker, Supreeth Venkatesh. I work as server manageability architect at AMD. I also represent AMD at industry standard forums like DMTF, PMCI Workgroup, and Redfish Forum. Today's agenda will include rationale moving towards open source OpenBMC, introduction, proof of concept on what we are doing, status and next steps, and finally call to action. Okay, so why open source OpenBMC? This is basically because AMD wants to show support to the open source initiative that is going on, and to be a model open source company. Without open source reference, customers, partners will create point solutions, which will lead to fragmentation in the AMD ecosystem. But with open source reference implementation, by leveraging industry standard management specifications, we'll be able to avoid fragmentation within the ecosystem, and customers, partners, end users kind of value standardized common manageability capabilities with scope for customizations. The other reason is to align with the general direction where the industry is headed on open source firmware stacks. Also collaborate with the partners, customers, to support AMD specific interfaces, and we would love your feedback on AMD specific interfaces so that we can open source those and provide you with a reference. All right, this shows a conceptual manageability diagram between the BMC and AMD server SoC. So basically, there are two out-of-band interfaces, industry standard DMTF Redfish and IPMI. And on the BMC, there will be a Redfish or IPMI engine, which caters to out-of-band requests. And on the in-band side, usually USB, LPC, SPI, PCIe lines, and UART lines are kind of used. USB lines in AMD's case is used for Redfish host interface, as well as keyboard and mouse control. And virtual media, this is for mounting ISOs to boot images, as well as virtual USB for transferring data between the host and the BMC. LPC SPI interfaces is mainly used for IPMI system interfaces like KCS, block transfer, BT, as well as the postcode snooping. PCIe 1X line is used for graphics video feature. This is to relay the video running on the host to the BMC, and then through the BMC to the client, which may be running anywhere in the world. UART is basically used for serial over LAN and console features. So thanks to OpenBMC, all these features are available as open source. And for AMD platforms, we just need to kind of port the code over and change the configuration details a bit here and there. So the next interface is interesting. It's the JTAG interface. This is basically used for remote debug. This is AMD specific and proprietary to AMD. We do have a remote debug client, which may be script based or graphical user interface based. It will communicate with the debug server that is running on the BMC, and the BMC will transfer the payload it receives from the remote debug client to the server SOC debug port, and relay the response from the server SOC back to the remote debug client. And that is how the general architecture for the remote debug feature is. So this is AMD specific interface. So that's the reason it is kind of shaded in green. So other than these interfaces to the host, BMC also has interfaces to the board components like sensors, FPGAs, EEPROMs, power voltage regulators. Usually they are over either I2C or I3C. And thanks to OpenBMC again, that there are standard references available, which we have ported over to AMD platforms and implemented these features. Similar to sensors, fans also have a standard TAC PWM inputs, which we have kind of implemented over in AMD platforms. And then there are GPIOs for monitor and control signals, as well as locator LEDs. So all these are comes with the standard OpenBMC reference, which we have ported it over. Other than this signals shown for the from the BMC to the server SOC, there may be other GPIOs to monitor and control the state of the server SOC. So the next interface is kind of AMD specific interface. This is the AMD specific sideband interface, as we call it. It is called APML, which is Advanced Platform Management Link Interface. This is an AMD standard specification that's out there in the public. So this comprises of SPTSI and SPRMI. SPTSI stands for Sideband Temperature Sensor Interface, which will get the temperature of the CPUs. And SPRMI stands for Sideband Remote Management Interface, which can be used for power capping feature, CPU power capping feature, as well as RAS feature. So this interface is over I2C or I3C and connected to one of the management controller, which is called a system management unit in AMD server SoC. BMC also has interfaces to IO devices like shared network controller, and then system BMC flash. So this is over SPI. So this is a reference code is available in OpenBMC, and we have ported it over to AMD platforms. Other than that, BMC kind of connects to NVMe devices as well. So the interface is PCIe vendor-defined messaging. There is a specification NVMe MI over MCTP, which we are planning to leverage to implement this interface. Other than the standard interfaces, which are shown in blue, AMD-specific interfaces are shown in green. There are non-standard interfaces where the BMC will not have any management network capability, and all the management is via the host. So that is shown in amber here. Okay, moving on. So we have done a proof of concept. We have ported over OpenBMC on AMD EPYC Ethanol X platform. We have our own Meta AMD repository, which has been created thanks to Brad and OpenBMC community. We have that in the upstream repository. We have upstreamed around 22 patches into Meta AMD repository. These include the basic bring up code to bring up OpenBMC on AMD EPYC Ethanol X platform. We have upstream device tree for AMD EPYC Ethanol platform to Linux kernel, which is available in this link. Device tree for AMD EPYC data platform will be upstream soon. So the right-hand side diagram kind of shows the KVM functionality working on AMD EPYC Ethanol X platform, thanks to Open Source OpenBMC. Okay, so what are we planning and what is the current status? So these are the current features that are implemented, like the power management, LEDs, locator LEDs blinking, then firmware update for BMC images. We have used OpenBMC's reference code for web-based user interfaces and ported over to AMD platform with some customization. We have implemented dbus based interfaces for post codes, basically because post codes on AMD platforms are 32-bit as opposed to 8-bit post code. Then SSH console enablement. This comes as part of standard OpenBMC reference with just the configuration which we had to provide. User management, not much configuration was necessary here. It was ported as is. Advanced platform link management. This is where we had to implement sideband temperature sensor interface to get the CPU temperature information. And this CPU temperature information is displayed to the user on the UI, graphical user interface, as well as the IPMI, as well as through IPMI command and Redfish APIs. APML SBRMI framework using the EPYC system management interface library has been integrated. It is just an application. There is no integration with IPMI or Redfish at this point. A keyboard, video, mouse has been enabled. Virtual media has also been enabled on AMD EPYC Ethanol platform. For keyboard, video, mouse enablement and virtual media, upstream code was sufficient and configuration was very minimal to the device tree. So the features planned next are APML SBRMI kernel driver. ESMI library is a user space library, which is a stopgap arrangement for now. We plan to kind of upstream the SBRMI kernel driver, based on which the CPU power management, power capping features can be implemented, as well as the RAS implementation will be through the APML sideband remote management kernel driver. We plan to utilize the latest Redfish specification out there and comply with that, and plan to utilize the IPMI v2.0 compliance specification as well. Okay, finally, call to action. We would appreciate if you collaborate with AMD to help create robust AMD standard interfaces so that it can be enabled in OpenBMC. We appreciate your review, and please log into MetaAMD's OpenBMC Git repository, and please feel free to provide your feedback, and your feedback will be greatly appreciated. Participate in Redfish DMTF work groups to kind of influence industry standard interface specification, so that to avoid fragmentation within AMD's ecosystem. A big shout out to Twitter team for help in navigating avoid known pitfalls and providing valuable feedback. For any technical discussions, please email the OpenBMC mailing list listed here with the subject Meta AMD. Thank you very much for listening in and hope you had an informative session.